Imagine a secret to living past 100 years, hidden not in a laboratory or a complex medicine, but flowing quietly from your tap. Picture a simple habit practiced by some of the healthiest and longest living people on the planet that can transform your energy, your mind, your metabolism, and even the way your body repairs itself every day. Today, we're about to uncover a wisdom so simple yet so profound that it has allowed ordinary people to live extraordinary lives well into their centenarian years. This is not a story about gimmicks or magic pills. It's about something you already have, something you can start using right now to support every cell in your body, protect your brain, strengthen your circulation, and nurture your natural defenses. By the time we finish, you will see how a single, mindful habit, drinking water the right way, can become a cornerstone of longevity, vitality, and true wellness. Stay with me, because what you're about to learn is not just about adding years to your life, but adding life to your years. Every detail, every tip, every insight is designed to help you harness the quiet, powerful potential that flows through you with every sip. By the end, you'll not only understand this simple secret, you'll be ready to live it. If you want, I can also craft an even punchier 60-second hook for the very start of the video that grabs attention immediately and keeps viewers glued until the end. Do you want me to do that? Hydration and longevity are deeply connected at the most fundamental level of human biology. Water is not simply a fluid we consume to satisfy thirst. It is an active participant in nearly every physiological process that keeps us alive. As we age, total body water naturally declines, circulation becomes less efficient, and cellular repair mechanisms slow down. Chronic, low-grade dehydration quietly accelerates this decline. When the body lacks sufficient water, blood becomes more viscous, meaning it thickens. Thicker blood forces the heart to work harder to pump oxygen and nutrients throughout the body, increasing strain on the cardiovascular system. Over time, this stress can contribute to hypertension, vascular damage, and reduced tissue oxygenation, all factors associated with aging. At the cellular level, water is essential for maintaining structure and function. Every cell relies on water to transport nutrients inward and move metabolic waste outward. Without adequate hydration, waste products accumulate more easily, creating internal stress that may trigger inflammation. Inflammation, particularly chronic low-level inflammation, is widely recognized as a driver of age-related diseases. Proper hydration helps maintain optimal circulation and kidney filtration, supporting the body's natural detoxification systems and reducing inflammatory burden. Water also plays a critical role in maintaining the elasticity of blood vessels. Healthy, flexible vessels allow efficient blood flow and stable blood pressure. Dehydration can impair endothelial function, the delicate inner lining of blood vessels, reducing their ability to expand and contract properly. Over decades, this contributes to vascular aging. By contrast, consistent hydration supports smoother blood flow and nutrient delivery to vital organs, including the brain. Brain health is especially sensitive to hydration status. Even mild dehydration can reduce cognitive performance, impair memory, and elevate stress hormones such as cortisol. Chronically elevated stress hormones accelerate biological aging by increasing oxidative stress. Adequate hydration supports stable energy metabolism in brain cells and preserves mental clarity, both of which are essential for long-term vitality. Hydration also influences metabolic health. Proper fluid balance supports mitochondrial function, the energy generators inside cells. When mitochondria function efficiently, cells produce energy with fewer damaging byproducts such as free radicals. This balance reduces oxidative stress, a key contributor to aging at the molecular level. Longevity is not achieved through dramatic interventions alone, but through consistent support of the body's repair systems. Water sustains circulation, detoxification, metabolic balance, temperature regulation, and joint lubrication. By maintaining these foundational systems daily, hydration becomes one of the simplest yet most powerful strategies for promoting a longer, healthier life. Water as cellular nutrition goes far beyond the idea that water is simply a neutral carrier. At the microscopic level, water is an active structural and functional component of every cell. Roughly 2/3 of the human body's water is found inside cells, where it maintains shape, electrical balance, and biochemical reactions. Without adequate intracellular hydration, cells cannot efficiently absorb nutrients such as glucose, amino acids, vitamins, and minerals. These nutrients depend on water to dissolve, travel through the bloodstream, and cross cell membranes. In this way, water acts as the medium that makes nourishment biologically available. Inside the cell, metabolic reactions occur in a water-based environment. Enzymes that drive life-sustaining chemical processes require proper hydration to maintain their three-dimensional structure. Even slight dehydration can alter enzyme efficiency, slowing energy production and repair mechanisms. Mitochondria, the structures responsible for generating cellular energy, depend on balanced fluid levels to maintain optimal electrochemical gradients. When hydration is sufficient, energy production is smoother and produces fewer damaging oxidative byproducts. Water also enables cellular communication. Electrolytes such as sodium and potassium dissolve in water to create electrical gradients across cell membranes. These gradients allow nerve impulses to fire, muscles to contract, and the heart to beat rhythmically. Without proper hydration, this electrical signaling becomes less stable, affecting everything from cognitive clarity to cardiovascular performance. Additionally, water plays a crucial role in removing metabolic waste. Cells continuously generate byproducts that must be transported out to prevent internal stress. Adequate hydration ensures that waste diffuses efficiently into the bloodstream and is delivered to the kidneys and liver for elimination. When waste removal slows, inflammatory pathways can become activated, accelerating cellular aging. Hydration at the cellular level is therefore not passive. It is nutritive, regulatory, and protective. By sustaining the fluid environment in which life's chemistry operates, water directly influences how well cells receive nourishment, generate energy, communicate, and maintain structural integrity. The timing of water intake influences how effectively the body uses it. Drinking water is not only about total daily quantity, but also about when it is consumed in relation to biological rhythms. After several hours of sleep, the body wakes in a mildly dehydrated state. During the night, respiration and perspiration continue, yet fluid intake stops. Consuming water immediately upon waking rapidly restores plasma volume, improves circulation, and gently activates the digestive system. This early hydration supports bowel motility, enhances kidney filtration after the overnight concentration of urine, and helps normalize blood pressure fluctuations that occur in the morning. Drinking water before meals also has measurable metabolic effects. When consumed approximately 20 to 30 minutes prior to eating, water begins to move through the stomach and primes gastric secretions without significantly diluting digestive enzymes. This timing can enhance satiety signals, leading to more balanced portion sizes and steadier glucose responses after meals. Stable glucose levels reduce oxidative stress and glycation, processes associated with accelerated aging. In contrast, consuming excessive amounts of fluid during large meals may temporarily dilute stomach acid, potentially slowing digestion in some individuals. Spacing water intake evenly throughout the day promotes circulatory stability. The body absorbs water gradually, and consistent intake maintains optimal blood viscosity and electrolyte balance. Large, infrequent volumes can overwhelm the kidneys briefly, increasing urinary output without maximizing cellular hydration. Sipping water at regular intervals allows tissues to equilibrate and support sustained nutrient delivery. Evening hydration requires balance. Small amounts of water maintain circulation and prevent overnight dehydration, but excessive intake close to bedtime may disrupt sleep due to frequent urination. Because sleep is critical for cellular repair and hormone regulation, preserving uninterrupted rest indirectly enhances the benefits of proper hydration timing. Aligning water intake with circadian patterns, digestive activity, and kidney function allows hydration to work in harmony with physiology rather than as a random habit. Hydration plays a direct and measurable role in circulation and overall blood health. Blood is composed largely of plasma, and plasma itself is more than 90% water. When hydration levels are adequate, blood maintains optimal viscosity, meaning it flows smoothly through arteries, veins, and microscopic capillaries. Efficient flow ensures that oxygen, glucose, amino acids, hormones, and micronutrients are delivered consistently to tissues. When the body is even mildly dehydrated, plasma volume decreases and blood becomes more concentrated. This thicker consistency forces the heart to pump harder to circulate the same volume, increasing cardiovascular strain over time. Proper hydration also supports stable blood pressure. When fluid levels drop, the body compensates by constricting blood vessels and releasing hormones that retain sodium and water. Chronic activation of these mechanisms can contribute to elevated blood pressure and vascular stiffness. Maintaining steady hydration reduces the need for these stress responses, helping blood vessels remain flexible and responsive. Flexible vessels are essential for protecting delicate organs such as the brain and kidneys from pressure-related damage. Red blood cells rely on balanced fluid levels to maintain their shape and deformability. Their flexible structure allows them to pass through extremely narrow capillaries to deliver oxygen efficiently. Dehydration can alter this flexibility, impairing microcirculation and limiting oxygen delivery at the tissue level. Reduced oxygenation increases cellular stress and may impair energy production. Hydration also influences clotting dynamics. Concentrated blood may increase the likelihood of clot formation in susceptible individuals, while adequate fluid balance supports smoother circulation. In addition, proper hydration aids the transport of metabolic waste products to the the kidneys and liver for removal, preventing accumulation in the bloodstream. By sustaining plasma volume, vascular elasticity, red blood cell performance, and efficient oxygen transport, consistent hydration helps maintain a circulatory system that delivers nourishment effectively and reduces mechanical stress on the heart and blood vessels. Water plays a subtle but important role in supporting metabolism and maintaining healthy weight balance. Metabolism refers to the complex network of chemical reactions that convert food into energy and building blocks for repair. These reactions occur in a fluid environment inside cells. An adequate hydration ensures that enzymes function efficiently. When the body is properly hydrated, circulation delivers glucose and fatty acids more effectively to tissues where they can be used for energy rather than stored excessively. Drinking water can also influence resting energy expenditure. Studies have shown that consuming water, particularly in moderate amounts, can temporarily increase metabolic rate through a process known as thermogenesis. The body expends energy to warm ingested water to core temperature, leading to a small but measurable increase in calorie burning. While modest on its own, this effect contributes to overall metabolic efficiency when practiced consistently. Hydration supports appetite regulation as well. Thirst signals are sometimes misinterpreted as hunger, leading to unnecessary caloric intake. Drinking water before meals can promote a sense of fullness, helping regulate portion sizes and reducing the likelihood of overeating. More stable portion control contributes to balanced insulin responses and steadier blood glucose levels. Large spikes in glucose and insulin over time are associated with fat accumulation, metabolic stress, and increased risk of age-related conditions. Water is also essential for lipolysis, the process by which stored fat is broken down for energy. Adequate hydration supports kidney function and reduces the burden on the liver, allowing the liver to metabolize fat more efficiently. When dehydration occurs, the kidneys conserve fluid and the liver may partially compensate, potentially slowing fat metabolism. Electrolyte balance, maintained through proper hydration, ensures that muscle cells contract effectively during physical activity. Efficient muscle performance increases energy expenditure and supports metabolic flexibility, the body's ability to switch between burning carbohydrates and fats. Through its influence on enzymatic activity, appetite signals, fat metabolism, and physical performance, consistent hydration becomes a quiet but foundational contributor to metabolic health. Brain function is highly sensitive to hydration status because the brain is composed of nearly 75% water and depends on precise fluid balance to operate efficiently. Even mild dehydration, as little as 1 to 2% loss of body weight from fluids, can influence cognitive performance. When hydration drops, blood volume decreases slightly, which can reduce the efficiency of oxygen and glucose delivery to brain tissue. Since neurons require a constant energy supply, even subtle reductions can impair attention, reaction time, and short-term memory. Water also supports the production and balance of neurotransmitters, the chemical messengers that regulate mood and mental clarity. Proper hydration maintains electrolyte gradients involving sodium and potassium, which are essential for generating electrical impulses across nerve cells. If fluid balance is disrupted, these gradients become less stable, potentially leading to mental fatigue, irritability, and decreased concentration. This instability can subtly affect decision-making and emotional regulation throughout the day. Dehydration is associated with elevated levels of cortisol, a stress hormone. When the body senses reduced fluid availability, it activates stress pathways to preserve circulation and maintain blood pressure. Chronically elevated cortisol can influence mood, increase anxiety, and contribute to sleep disturbances. Over time, persistent stress hormone activation may also accelerate cellular aging in brain tissue by increasing oxidative stress. Adequate hydration supports the brain's lymphatic system, a waste clearance pathway that becomes particularly active during sleep. This system relies on fluid movement to remove metabolic byproducts that accumulate during waking hours. If hydration is insufficient, waste removal may be less efficient, potentially affecting long-term brain resilience. Hydration also influences perceived energy levels. Feelings of sluggishness or mental fog often improve after drinking water because circulation stabilizes and neural signaling becomes more efficient. By maintaining fluid balance, the brain preserves electrical stability, nutrient delivery, stress regulation, and waste removal processes that collectively sustain cognitive sharpness and emotional balance. Water plays an essential role in gut function and the health of the microbiome, the vast community of microorganisms living in the digestive tract. Digestion begins with saliva, which is primarily composed of water and contains enzymes that initiate the breakdown of carbohydrates. Adequate hydration ensures sufficient saliva production, supporting smoother swallowing and early-stage digestion. As food travels to the stomach and intestines, water helps dissolve nutrients so they can interact effectively with digestive enzymes and be absorbed through the intestinal lining. In the stomach, Proper fluid balance contributes to the formation of gastric juices that assist in breaking down proteins and other macronutrients. As partially digested food moves into the small intestine, water facilitates the mixing of bile and pancreatic enzymes, allowing fats, carbohydrates, and proteins to be further processed into absorbable molecules. Without sufficient hydration, this process may slow, leading to discomfort, bloating, or inefficient nutrient absorption. Water is also critical for maintaining the mucosal lining of the intestines. This protective barrier prevents harmful substances and pathogens from entering the bloodstream while allowing beneficial nutrients to pass through. Adequate hydration supports the integrity of this lining, reducing the likelihood of increased intestinal permeability, which has been associated with inflammation. The microbiome depends on a balanced intestinal environment. Beneficial bacteria thrive when digestive transit is regular and the intestinal contents have appropriate moisture. Water softens stool and supports peristalsis, the wave-like contractions that move food and waste through the colon. When hydration is inadequate, stool becomes harder and transit slows, which can disrupt microbial balance and promote the growth of less favorable bacterial strains. Proper hydration also assists in the fermentation process carried out by gut bacteria, which produce short-chain fatty acids that nourish colon cells and influence immune regulation. By maintaining digestive fluidity, supporting mucosal defenses, and promoting regular elimination, water contributes to a stable microbial ecosystem and overall gastrointestinal health. Kidney detoxification depends fundamentally on adequate hydration because the kidneys regulate fluid balance, filter blood, and remove metabolic waste products. Every minute, blood passes through tiny filtration units in the kidneys called nephrons. These structures separate waste compounds such as urea, creatinine, and excess electrolytes from useful substances that the body needs to retain. Water provides the fluid medium that allows these waste products to dissolve and be excreted efficiently in urine. Without sufficient hydration, the concentration of waste in the bloodstream rises, increasing the workload placed on the kidneys. When fluid intake is low, the body conserves water by producing smaller amounts of more concentrated urine. This higher concentration increases the risk of crystal formation, which can contribute to kidney stones. Concentrated urine may also irritate urinary tract tissues and reduce the efficiency of toxin elimination. Over long periods, repeated strain from chronic low hydration can impair kidney filtration capacity and elevate the risk of kidney dysfunction. Proper hydration supports stable blood flow to the kidneys. Because these organs receive a significant portion of cardiac output, maintaining adequate plasma volume ensures consistent filtration pressure. If dehydration reduces blood volume, the kidneys respond by activating hormonal systems such as the renin-angiotensin-aldosterone pathway to preserve circulation. Chronic activation of these systems may contribute to elevated blood pressure and vascular stress. Water also assists in balancing electrolytes like sodium and potassium, which are tightly regulated by kidney function. Stable electrolyte levels are essential for nerve conduction, muscle contraction, and heart rhythm. Adequate hydration helps the kidneys fine-tune these levels without excessive strain. Efficient removal of metabolic byproducts reduces systemic inflammation and oxidative stress. When waste compounds accumulate, they can disrupt cellular function and promote inflammatory signaling. By supporting consistent urine production and toxin clearance, proper hydration enables the kidneys to perform continuous internal cleansing that protects long-term organ health and overall physiological stability. Hydration plays an important regulatory role in controlling inflammation, particularly the kind of low-grade chronic inflammation associated with aging and many degenerative conditions. Inflammation is a natural defense mechanism designed to protect the body from injury and infection. However, when inflammatory signals remain mildly elevated over long periods, they contribute to tissue damage, vascular stiffness, metabolic dysfunction, and accelerated cellular aging. Adequate hydration helps modulate several biological pathways that influence this balance. At the cellular level, dehydration creates physiological stress. When cells lose water, their volume decreases, and this shrinkage can trigger stress signaling pathways. These signals may stimulate the production of pro-inflammatory molecules as the body attempts to restore balance. Maintaining proper fluid levels helps preserve cellular integrity and reduces unnecessary activation of these inflammatory cascades. Stable hydration supports optimal blood flow, ensuring that oxygen and nutrients reach tissues efficiently while metabolic waste is removed promptly. Accumulated waste products can act as irritants that stimulate immune responses and promote inflammation. Hydration also supports the function of the lymphatic system, which helps clear cellular debris, pathogens, and excess proteins from tissues. The movement of lymph depends partly on fluid balance and circulation. When hydration is adequate, lymphatic flow is more efficient, contributing to immune regulation and reduced inflammatory burden. Poor hydration may slow this clearance process, allowing inflammatory mediators to persist longer in tissues. Blood viscosity influences inflammatory dynamics as well. Thicker blood associated with dehydration can increase mechanical stress on blood vessel walls, potentially stimulating inflammatory responses in the endothelium. Consistent hydration helps maintain smoother circulation and protects vascular lining integrity. Additionally, proper hydration supports temperature regulation through sweating. By preventing overheating and excessive physiological stress, water indirectly reduces stress hormone release, which can otherwise amplify inflammatory signaling. Through its effects on cellular stability, circulation, lymphatic flow, waste removal, and stress regulation, hydration serves as a foundational factor in maintaining balanced immune activity and minimizing chronic inflammatory strain. Longevity habits extend beyond hydration, emphasizing the interplay of diet, movement, mindset, and daily routines in promoting a long, healthy life. While water is foundational, it works most effectively when combined with consistent lifestyle practices that reduce stress, support metabolic balance, and enhance cellular repair. Dietary choices influence inflammation, energy availability, and microbiome health. Consuming nutrient-dense, plant-forward foods supplies antioxidants, fiber, and essential micronutrients that protect cells from oxidative damage and support organ function. Minimizing processed foods, excess sugars, and trans fats further reduces chronic stress on the body, complementing the benefits of proper hydration. Regular physical activity is another critical component of longevity. Exercise stimulates circulation, strengthens the cardiovascular system, supports metabolic flexibility, and enhances the efficiency of waste removal through sweat and lymphatic movement. Muscular activity maintains joint health, bone density, and metabolic rate, all of which are essential for maintaining independence and resilience with age. Movement also improves mood and cognitive function, reinforcing the connection between physical and mental well-being. Mental and emotional health practices are equally important. Stress management through mindfulness, meditation, or purposeful routines reduces the release of cortisol and other stress hormones that accelerate cellular aging. Social connection and engagement with community foster a sense of purpose and belonging, which research consistently links to longer lifespan and improved cognitive health. Sleep quality and consistency also contribute to longevity, allowing the body to repair DNA, regenerate cells, and regulate hormone cycles. Finally, simplicity and consistency in daily habits reinforce these principles. Small intentional routines, like timed hydration, mindful meals, and moderate activity, create cumulative benefits over decades. By integrating these practices, the body experiences reduced inflammation, optimized organ function, stable energy balance, and enhanced resilience to stressors. Hydration becomes part of a holistic system of lifestyle choices that collectively support health span and the potential to reach advanced age while maintaining vitality. In conclusion, the journey to longevity is beautifully simple yet profoundly powerful. Drinking water the right way is not just about quenching thirst, it is about nurturing every cell, supporting circulation, aiding metabolism, protecting the brain, and enabling the body's natural detoxification and repair systems. When combined with mindful habits such as a balanced diet, regular movement, quality sleep, stress management, and social connection, hydration becomes a cornerstone of a life lived with vitality, resilience, and purpose. Remember, the secret of living long is not in chasing complexity or searching for a miracle. It lies in honoring your biology, creating rhythm in your daily habits, and making small, consistent choices that amplify health over decades. Each glass of water you drink is an investment in your cells, your organs, and ultimately your future. I wish you all the very best on this journey toward a longer, healthier, and more vibrant life. May every sip you take bring you closer to strength, clarity, and the joy of well-being. Thank you for your time, attention, and commitment to nurturing yourself.